Okay, welcome back to the final unit of the year. It's going to be chapter 9. I know it's in kind of the middle of the book, but we'll come back to it. It's the conics unit. So today, it's kind of out of place though with the conics, but because of where it falls, so be it. I can calculate the midpoint and distance of a line given 2 points. Distance and midpoint. We've done this before. It should be a piece of paper. Okay. Formulas are on page 614 in section 9.1. If I want to find the midpoint of a line, basically I take the x coordinates, add them together, the y coordinates, add them together, and divide by 2. So here's 2 points, 8, 4, and negative 1, 2. I call this one x1 and y1. And I call this one x2, y2. So algebraically, you want to find the midpoint. I say 8 plus a negative 1 divided by 2, and I say 4 plus a negative 2 divided by 2. 8 plus a negative 1 over 2, that's negative 7 over 2, and negative 4 over 2, that's 2 over 2, which is 1. So 7 halves, or you might do it as decimal, 3.51. That's the midpoint. Let's see what that means when we plot everything here. 8 and 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Here's 8, 4. Negative 1, negative 2, over 1, down 2. Negative 2. There's our points. If we connect them, there's our line. Well, when we plot the midpoint, 3.5 and 1, to 3.5 up 1. To me, that looks like that's pretty much in the middle of the line. 3.51. So when you calculate a midpoint, it's a good way to kind of give yourself a visual check. Plot the endpoints and the midpoint together in one graph. If you see if you're right or not. If your midpoint is not on the line, it's off the line, or it's way closer to one end than the other, then you might have made a mistake. You should go back and check it out. So let's look at distance then. Distance is the difference of the x's squared plus the difference of the y's squared, then all square rooted. We've done this before. So 8 minus a negative 1. It doesn't matter which order I subtract them because the squaring part cancels that out whether it's negative or positive. Y2 minus y1, 4 minus a negative 2. Okay, now I did them completely opposite, didn't I? Because I have x1 and x2 flip-flop. If I did negative 1 minus 8, that'd be negative 9. I'm going to get a positive 9. When I square negative 9 or I square positive 9, I get the same thing. Same thing here, negative 2 minus 4 to a negative 6. I'm going to get positive 6. If I square it, it doesn't matter which order I subtract them in. So I get 81 plus 36. 81 plus 36 is the square root of 117, which is approximately 10.8 units. Okay? So we could break down the square root of 117 too, using our perfect square list. Square root of 9 times the square root of 13, which is 3 square roots of 13. If it asks you for the exact answer, that's what this is. This is the approximation in decimal version. I'm not going to make too big of a deal either way, but that's what you're looking for. So now let's do an ACT type of problem. ACT is not going to say what's the midpoint of a line. That's too straightforward. What they may do is say here's a line A to B. I'm going to give you one of the endpoints, B in this case, and a midpoint M. What is the coordinate of A? So if M is our midpoint, 1, 5, over 1, up 1, 2, 3, 4, 5, here's M. And B is our coordinate 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Here's B. We know that A has to be over here somewhere, doesn't it? A has to be on this side. So keep that in mind when we're going to solve for A. So our midpoint says, okay, our midpoint is 5, 6. So our midpoint formula is x2 plus x1 or vice versa over 2, and y2 plus y1 over 2. It doesn't matter whether we write y1 or y2 first, or x1 or x2 first. So let's use that to our advantage. We know the x-coordinate of the midpoint is 1. So 1 has to equal 5 plus some x1 coordinate. And we know that our y-coordinate of the midpoint is 5. So 5 has to equal 6 plus some y-coordinate. So we can solve these equations, each of them, for the midpoint. Okay? Oops, and I forgot. Divided by 2. We're divided by 2 part for each other. That's that'll make a big difference, right? So we can find each of these coordinates by solving backwards for each part of the formula. So now instead of solving for m, the midpoint, we're solving for an endpoint. So in each of these situations, we're going to start out by getting rid of the denominator. Okay, we're going to multiply each side by 2. 2 equals 5 plus x sub 1. Subtract 5 from both sides. We end up with, negative 3 equals x sub 1. And over here, if we do the same thing, multiply by 2. Multiply by 2. We get 10 equals 6 plus y1. Subtract 6. We get 4 equals y sub 1. So the xy coordinate for A, put that together. A is negative 3, 4. Let's see if that works out when we plot it. Left 3, 1, 2, 3, up 1, 2, 3, 4. I would say that puts a nice endpoint to the line AP with M being in the middle. So that is it. That's all. That's all we have for today. Midpoint and distance. We'll have some practice for you in class tomorrow. Have your notes ready to be checked. And we'll see you later.